Hello, Jermaine here, and welcome to this fourth video. Last time, what we did was we mainly focused on integrating our RESTful endpoint with a Postgres database. And we went doing that by creating a serializable class. First, we looked at serializable classes and what they were used for. And essentially, these are useful when dealing with request payloads. So we created a subclass from serializable, and then we had to override two methods in particular. So reading from map. So what this read from map did was it took the payload from our request body, assuming it's a JSON structure, and then it decoded it, and we're able to essentially assign properties from our JSON structure to members of this serializable subclass. And then we created an asMap function, which that essentially does the other way around. So it will take members from our subclass and then it will produce a map object for it. So this was useful when returning a response, essentially to the client, a JSON response. And then from that, we moved on to creating managed objects, which are responsible for interacting essentially with our columns in our database. And we created a subclass of that called read. And I mentioned that all the properties we define here are transient. So you would define any sort of computed properties here, which will not be persisted in the database, but then these are computed based on the data in our actual database columns. So from all of that, we therefore proceeded to create a data model, and then we connected to our database. And then from that, we created a managed context, which took in our data model and then our persistent store, so our database connection information. So this context now allowed us to talk to our database and perform various queries on it. And then I'll bring us back to reads controller. So in here now was where we decided to use our managed objects by creating these query objects, which took the context. And then from these query objects, we're able to perform various operations. So from fetching to inserting to updating to deleting. Okay, so in this video, we're going to be looking at configuration files. So how to use configuration in our Aqueduct application, and also we'll be looking at writing tests for our Aqueduct application. So at the moment, there are no tests for this. So we're literally like spraying and praying. Yeah, we're literally spraying and praying. So we're gonna write some tests, so at least we have a bit more confidence that that our application would work the way we expect it to. I'm not gonna go into the benefits of unit testing. I imagine people watching already have an idea of that anyway. So let's begin. So in the very first video, I mentioned that our startup file is located in the bin folder here. So in bin.main dot, we're creating an application object and we're starting the application here. So far, whenever we've been running our Aqueduct application, we've been doing Aqueduct serve. And I mean, this is a convenience command given us by the Aqueduct team, basically. But Aqueduct serve does not run this file directly. So Aqueduct serve has got an internal template to the framework that it runs to start up the server. So the template looks similar to that, but it's not this exact file that it runs to start the server. So if you want to run this exact file, for example, when deploying to production, you want to do dart bin then main.dart. So dart command and then the location of our main.dart file. So doing that would run this exact file as expected here. Okay, so that's that's good to know. But for now I'm still gonna just do Aqueduct serve in this case. Close this. Okay, so the other thing I wanted to mention was if we come here to our reads endpoint, we see the results as expected, but in this managed object subclass, essentially, I mentioned that these were computed properties, but then you can see that they're not included in the response, which is because we need to annotate it with an annotation called serialize. So doing this, if I save this and I restart the Aqueduct server, loading. Okay, so now if I try again, we can see that it's now included in the response from the server. So always you need to annotate your properties, your transient properties with the serialized annotation in order for it to be included in a response. So I'll leave that there. Now I will draw your attention to channel.dart. So there's a problem here. One of the problems is that we're defining our database information in this file directly, and this introduces two problems. So the first problem is that it implies that we're using the same database for our local environments, for our testing environment, for our production environment. And of course that's not the case. And also the second thing is that we are persisting this information in source control. So I mean, I'm committing all these files to GitHub, and you're able to see all these details here, which is obviously a security risk. So one of the things we can do is we can create configuration files, and then we're able to load our configuration files in here. So which means that we can create different configuration files for different environments, and then we'll use them as and when we need. Now, so to do that, we will, let me clean up some of this bits. Okay. So let's create a configuration file for our reads. I'll call it read config, and we need to extend a class called configuration. So what configuration is, essentially it's able to read data from configuration files, and it allows us to declare the expected properties we want from our configuration files. So if you look at the generated Aqueduct project, you notice that there are these files here, config.yaml and config.src.yaml. So these files are where we will store our configuration in it. So we'll start our configuration here, and then in channel.dart we're able to extract the details from this configuration file. So the first thing I'll do is I'll come to config.yaml, and in fact before I resume, so the main difference between these two files is you would have your config.yaml file as your production file, and then config.source will be a file that you would use for unit testing. So that furthermore, that means that we don't commit config.yaml into source control. So at the moment it's committed to source control, but we're gonna deal with that later on. Hopefully I'll remember. And but config.source.yaml, you're able to commit that to source control, since that will contain test information anyway. Okay, so I'll come back to channel.dart. I'll create a subclass of configuration called readConfig, and then in my constructor I'll take a path, and then in my initializer I will invoke the parent constructor, specifically from file, which is a named constructor. So if I go to the definition for configuration, we see that there are various constructors we get. So we got configuration from map, so we can pass it a map object. We got configuration from string, and we've got configuration from file. So that's what we're doing here, and essentially we'll pass in a file object containing a path to our config.yaml file, and then it will be loaded in here. Okay, so super from file, and then I'll create file object, and then I'll pass our path in it. Okay, so that's the first thing I'll do. And then the second thing I need to do is create a configuration for our database. So the type is database configuration, which is a type of configuration file that contains details about our database, essentially. And then I'll call it database. Okay, so in order to make sense of this, we need to come back to our config.yaml file and define information for our database. So it will start with a top level property called database, which is the name we're using here. And if we go to database configuration, so I'm going to go to the definition here, and if I scroll down, we can find that there are some properties that are required and optional. So we need to define a host, a port, a database name, and these are optional, but because we are connecting to our Postgres with a username and password, we need to define these as well. So username and password, and we leave this out for now. So I'm going to do exactly this. So go to the config.yaml file, and then we need to define a username, a password, a host, a port. So our host is localhost, the port is 5432, the username is, I need to come back to this file. So favorite user is our username, password is the password. I've done the host and port already, and this is our database name. So I'm going to do exactly that. So favorite user is our username, password is password, and then our database name is favorite official. All right, so I'll save this file, and then I'll come back to channel.dart, and I will create a variable called config, which will be an instance of readConfig, and then which takes a string with the path in it. So it will be config.yaml file here. So what's happening here is when we start while preparing, this readConfig will proceed to load this file and will extract the database information in it. So if I decide to print, for example, config.database.host, so if I decide to do that, start Aqueduct serve again, we should see localhost printed out in the console. So give it a moment. Yeah, there we go. You got localhost printed there. Okay, so it's working. We're able to extract that information there. So now we can do config.database.username, and then do the same for the rest. I'll speed this up. Okay, so let me save this file, restart our Aqueduct server, and then I'm going to test this out. Okay, so let's test this out by clicking send, and yep, it's still working. Okay, that's good. So as well as passing in the string to our config.yaml file, we're also able to use a property which is part of this application channel called options. So it's called options, and let me come to this. Let me go to its definition and then show you what options is. So if I scroll down, yeah, you see options here, which is application options. So these options essentially capture command line arguments that are passed into our Aqueduct application. So whenever we do Aqueduct serve, there's a command line argument defined for a path to the configuration file. So that by default is defined for us. So I mean, if you read the details, it says the path is provided when an application is started with a config path option to Aqueduct serve. So fortunately, though by default Aqueduct serve sets this file path to our config.yaml file. So I'll just use this instead of passing the string in directly. So let me save this file, run Aqueduct serve again, give it time to load. Okay, so I should be able to do, okay, I'm able to do a get. Let's see if I can get a third one. Okay, that's good. It's got details. Let's do a post. Do a post. And we get a 405 method not allowed because I've got the wrong URL. Let's try again. Post, okay. So it returns the results, and as you can see, it also includes our detail transient property because we annotated it with the serialized annotation. So now if we go to get, we're able to see code complete here. So that's good. So let's try doing a put, and let's update. Okay, let's update 7th and call it updated, and let's send this. Okay, it's been updated. That's good. So if I do a get, it returns updated. Okay, and let's delete it. So now deleted. If I do a get, should get 44 not found. Yep, that's perfect. Okay, so now that we've taken out all the hard-coded strings in favor of configuration files, Now what we can do is we can keep this file out of source control. If I kill this, and using git, I can do git rm cached, and then the name of our file. So git cached config.yaml. So this file is now outside of source control, and then in our git ignore file, I could say that I don't want this file in here. So I can just do that. Okay. So at this point, we are going to be writing our unit tests for our endpoint. Before we get into testing, I need to mention one thing. So in our config files, as well as specifying each value as strings or numbers, we can also define environment variables. So in here, so let's say if you're deploying to somewhere like Heroku or Google Cloud and whatnot, those kind of platforms allow you to set environment variables which contain these values essentially. So you can actually base this file on environment variable values, which means that you can still persist this in source control. So to create an environment, to define an environment variable, you just need a $, followed by whatever the environment variable is. So database host or something along those lines. So database host, and of course with the port, we start with the $, and then it will be database port and so on and so forth. So that's useful to know. I'm just gonna ignore that for now, and then now we go to testing. So all tests for a Dart application goes in a test folder here. So if you open the test folder, you see that they've as part of the Aqueduct project generation tool, it generates an example for us. So we got this example test here, but this example test relies on this harness. And what this harness does is essentially it, as the name suggests, it creates a test harness which manages the life cycle of your application. So starting, running tests, it helps you manage all the life cycle for that. And this harness contains methods you can override. So on setup, on teardown. So setup allows you to define whatever you define here will be called will be run before each test case essentially, and on teardown, as you guessed, will be called after each test case. So the initial steps we need to take in order to allow us to use this harness is to set up our database, our test database, because at the moment in config.source.yaml we don't have any information for our test database. But to do this, first we need to using the Postgres app, which is it's loading, should open soon. Okay, so we actually need to create our database here. So the command will be create database. Okay, let me try that again. Create database, and then the name of our database would be favorites official test, and I'll remember the semicolon now. And then what we'll do is we'll grant all on database, the database we created. I think we can do create a DB which is a reference to this database we just created. And we want to give that to favorites user. I believe that's the user we created already. Creator DB doesn't exist. Okay, never mind. I will just go back to okay, fine. So now that our test database is created, I can just close this and then come to our config.source.yaml file, copy the contents of config.yaml in here, and then we just need to change this to test. And yeah, everything else should remain the same pretty much. Okay, so now that we've got the configuration for our test database, we'll come back to our harness.dart file, and what we need to do next is to upload our database schema to the test database we just created before each test. So fortunately, we can do that here in our harness, and we need to use a mixin that comes with Aqueduct called test harness ORM mixin, and that gives us access to a method in here called reset data. So on setup, we'll perform a reset of the data, which will basically just clean the database and put it in a pristine state before each test. And we also need to define a managed context. That's how we're getting this error. So we need to define context, which is a managed context. So we need a getter for this one. And then what this will return is our favorites channel here. So essentially the context in here, we're going to assign it to this one. So channel.context, and that should get rid of the error. Okay, so I can save this file, and then I can come to this test file. And so we've got an example here of how to use our harness. So essentially we create a harness object, and then we'll invoke the install method, and using the cascade operator just ensures that the harness instance is returned, because that's what we need in order to make request calls to our endpoint. So in this example, we're using the harness object, and we're using the agent, and we're performing a get request to this endpoint. And of course, we're expecting that a 200 response will be returned with this key value pair. Now, I'm not going to run this test because it will fail. We don't have this example endpoint. I got rid of it in the earlier videos. So what I'll instead do is I'll create a new file. I'll call it reads controller test.dart. And it's important that you name these test files with _test, or else this file will not be run. So that's important to know. And what I'm going to do here is I'm going to import the harness, and then define the main function, and then we'll create a harness object, then invoke the install method. The install method would start and stop our application, and then we'll write our first test case. So doing a get to our reads endpoint returns a 200 response. and I'll mark this with async. So in here, we'll create a variable called response, and then we'll perform our request using the agent that comes with our harness. So harness.agent dot, we're making a get request to read, and this returns a future, so we'll use await here, and then we can perform an expectation on the response. So expect the response sys status code to be 200. So something along these lines, and I'll delete example.test. I'll delete this file. Okay, and then let's try and run this by doing, well, two ways. We could simply click this run, link here, and yep, it looks like our tests are passing, so that's good. But then alternatively, what I was going to do was to type in pub run test in the terminal. So if I type this out, that will also run the test for us. But because I've got the Dart and Flutter extensions installed, I'm able to just click this run link here, which I think is a lot simpler by doing pub run test. Okay, so I am going to go to our reads controller, the Dart file, and we need to see the test that we need to write. So looking here, we got, okay, so for get, essentially we, I guess, can just ensure that a response is returned with an amount of items. So let's try that. So aside from expect, we can also do expect response, which takes in a response and then the status code, and then it takes a named parameter called body, and then we can have expectations on our body. So let's say it has a length of 1 or something like that, and let's run it. Let's see what happens. Okay, so we can see that our test fails, which is, yeah, because it's empty, which is expected. So we need to essentially populate our database before we can perform this request. So to do that, I am going to define a setup function here. Set up with a capital U. Mark this as async, and this setup would run before each test case, essentially. So I'm going to populate the database with some test information. So to do that, I will start by importing our managed object read.dart. So that means that I'm able to create a query object read, and then it takes in a context that we can take from our harness, application, channel, context. And then from that read query query, we can essentially we can define some values. So values would be values is essentially a reference to our read object. So essentially we will do something along the lines of that. Can I copy this? Okay. Now I'll just type it out manually. So each read takes in a title. So head first, design patterns, and then what else does it take? An author, takes in a year, and I'll just leave out the detail. Don't need that one since it's a transient property, it's not persisted in the database anyway. And from here I'll await. I'll do a read query.insert. So now this should pass, hopefully. So let's run this and see what happens. Yep, it passed. Okay, that's good. At this point, it's worth explaining where top level functions like has, length, and expect response come from. And the answer to that is if we look at our pubspec.yaml file. So there are two packages used when testing Aqueduct applications. So we've got Aqueduct test by the Aqueduct team, and then we've got test, the test package, which is by the Dart team. So if we go on their pages right now, here's the Aqueduct testing library, which allows us to set up various things like our test harness and the test harness ORM mixin that we used. All of it comes from Aqueduct test. And these are some of the functions that we can also use to check our responses. So if I zoom in a bit, so we use expect response, for example. We can use has body and has headers and all these other ones. And then if we come to the test Dart package, this is essentially the go-to package for writing and running unit tests in Dart. This would give us top level functions like test and expect and group for grouping various tests. So all of that, these functions come from this test package. And then there's also the matcher library, which is pulled in by Aqueduct test. That also allows us, it gives us access to more matcher functions to run. So all these functions are here. So any element contains all, contains, and so on and so forth. So in our first test, I was using this one, has length, and which is because it's from this package, which is pulled in as a dependency by Aqueduct test. So when writing tests, we're using these three packages in effect. So let's go back to the code. And then if we come back to our test, I'm going to amend this. Instead of doing has length, I will do every element. So I'll say, I want to check that every element. So yeah, I want to check that every element has an ID, which is, you can use the greater than matcher function greater than 0. I want to check that the title is string. I want to check that the author is also string, and I want to check that the year is an integer. Okay, so let's run this again and check and see what happens. Okay, so we got a failure, and then what's happening? Of course, we've got detail in the response as well. So when using every element, we're essentially saying that we want each item to have this exact structure, but then we did amend. We did say we wanted detail to be included, so that's from here. So we marked it with serialized. So detail is included in the response, so we need to capture that in the test. And yeah, this is the test file. So let's just include detail here, and I'll say detail is string. So if I run this test again, yeah, that passes. Okay, that's good. But aside from that, if let's say you had like 10 different properties, and with this, in this case, you may have to list all of them, but there's also another method we can use called partial. And a partial would partially match a part of the structure. So if I do partial, I can, for instance, get rid of the detail bit, and then I'll run the test again. And as you can see, it passes now. So I don't have to worry about detail. But I will, yeah, actually I'll just leave that. I'll leave it this way. So let's write our next test, which is that we want a get request done to read, then our path variable returns a single read. So we'll mark this as async as well, and then create our response. We'll perform a get request. And then our expected response would be a 200, and the body would be an object containing an ID, our title, which is this one, let me change this quickly. Use single quotes, title, head first design patterns, author Eric Freeman, and then the year be 2004, and then we want the detail would be head first design patterns by Eric Freeman. Okay, so let's test this out and run this. Okay, awesome. So that's also passing. Okay, so we can write more tests for our post, our put, and our delete essentially. So I'm gonna just make a list of to-do comments here. So for our post method, we want to say post reads would create a new read, and then for our put, we'll say put reads ID updates a read, and then if we do a delete slash reads, it will delete a read. Alright, so our first test is as follows. So let's define our test. Close that off, and final response. Then we'll perform a post request to reads, and then we specify a body for the request. So it'll just be an object containing essentially this information here. So I'll copy this and I'll paste it in here. So let me save that, and then we can expect our response to be 200 and it be an object. So it will be an object containing all this information, including our ID, which is set to 2, and that also includes detail, which the detail will be code complete updated by the author, Steve McConnell, 2 L's. Okay, so I saved it. Let's run it. Okay, perfect. That passes. Okay, this is going pretty smoothly. Okay, let's write the test file put. Mark it as async. Final response. Await harness .agent .put reads, and then we'll do it to 1 since we only have one item in our database. So we'll update that one with the body, and the body for that would be I'll copy this and then just call it updated. Really, yep, that should be good. And then in our expected response, it'll be 200, and then the body should be our ID would be 1 still, and then just use all these details. And there should be now a detail that says head first design patterns updated by Eric Freeman, and it's expect response. So let's run this. Okay, good, that passes. Okay, and now it's left with our delete. So I'll do a test again. This should be predictable at this point. So mark it as async. final response, it will be await for harness to delete reads 1, and then we expect our response to be 200, and then the body would be deleted 1 items. Let me in fact confirm this. So if I come to read control, I come to our delete. Yeah, essentially that's what we're doing. We're doing deleted, then the delete count items. Okay, so I can go back and come back to the test, and so I save this and then I run this, and hopefully all our tests should pass. Yeah, that's good. Okay, you can also write a couple more tests, because if we come to our read controllers, we need a test to capture this case. So if no items were deleted, we want a 404 response to be returned instead. So let's write a test case for that. So if I return to my test file and I do test delete read /2, returns a 404 response. So I'll mark it as async, and then we'll create a response object and perform our delete request. Agent delete reads 2, and then we should expect our response would be a 404 response, and the body should be I think it was item not found, but item not found. So let me just copy that into the test. Oops. Okay, so save that, run this test, and then it passes. Okay, that's good. And we need to do the same essentially for the other requests. So for a put request, we're also doing a 404 case, and also for get fetching a particular ID. So let's do that quickly. It should be pretty quick. Let me make the screen bigger. So if we come to our get, I'll say test get reads 2 returns a 404 response. So in here we'll create a response object. We'll await harness.agent.get reads item 2, and then the expected response will be a 404, and then the body will be item not found. So if I run this, yeah, perfect. Okay, so we need to do this for our put request. So I'll just copy and paste, and I'll make this a put, and I'll change that to a put, and I think that should be it really. Let's run. Okay, that failed. Why did it fail? Missing required body. Oh yeah, of course. So with our put request, we need to give it a body, and I'll just copy this, paste it, and it's body. So that way. Okay, so if I save this and run, okay, perfect. We got all our tests passing. All right, so just to recap on what we've done so far, we now have tests defined for our written for our reads controller endpoint, and we started by essentially defining our configuration to connect to our test database. So we created our test database and we defined the configuration to help us connect to that database. As I mentioned, all test information will go in config.source.yaml, and all information for production will go in config.yaml. You don't want to have your information, the actual values, persisted in source control. So you can, instead of doing this, you can either exclude this file from source control, or you can use environment variables. So if I do $$ symbol followed by the name of my environment variable will be database host, and you can do that for the rest of these. So at least you'll be able to commit this file into source control. You'll be able to have it version controlled, because all your values are in the environment. And then we looked at our harness, which essentially handles the lifecycle of our tests, running and stopping it. We're also we've defined an onSetup function that is called in between tests. So what this would do is it resets the data in our database and restores it to a pristine state, to a clean state, before each test is run. And then we created reads controller underscore test.dart, and we started by installing our harness, or starting our application, which meant that we were able to perform various requests to our endpoint using the agent that's part of the harness. And each test includes a setup whereby we populate the database with an item, so head first design patterns and so on and so forth. So now we have our tests fully defined for our endpoint. So we got get test, we got post, put, delete. So let me run this one more time, this time doing a pub run test. And hopefully all tests are passing. Okay, that's good. So I'm going to leave this video here. I hope this has been helpful, just to help you grasp testing, Dart applications, Aqueduct apps in general. As always, if you enjoyed this video, please let me know down in the comments below. And I also want to say a big thank you to all those that have asked questions in the comments, that have shown a general interest in the content that is being presented here. So very big thank you for that. If you enjoyed this video and would love to learn a bit more about Dart, consider subscribing to my channel. That'll be very helpful. I aim to release videos on a weekly basis. So do subscribe and hit the notification bell icon so that you are notified when new videos are released. Thank you.